Okay, well, welcome everyone. My name is Jamie McAvoy. I'm the Associate Director at the Water Resources Research Center and very happy to be hosting our webinar today. I'd like to remind you as attendees to please keep yourselves muted. At the end of our presentation, there will be a Q&A and your questions can be entered using the chat function at the bottom of your screen. And this recording will be posted on our website if you'd like to reference it after the talk today. So I'd like to start with a land acknowledgement. We respectfully acknowledge the University of Arizona is on the land and territories of Indigenous peoples. Today, Arizona is home to 22 federally recognized tribes, with Tucson being home to the Otham and the Yaqui. The university strives to build sustainable relationships with sovereign Native nations and Indigenous communities through education offerings, partnerships, and community service. I'd like to draw your attention to 3 upcoming events that are listed on the screen there. On April 11th, we'll have a webinar on advanced water purification in Arizona with Troy Hayes, Kevin Rose, and John Kamik. April 15th, we'll have a webinar on charting paths forward for the High Plains Aquifer in Kansas with Jim Butler. And on April 16th, we'll have the WRRC is co-sponsoring a Native Voices in STEM event, the Spring 2025 seminar, Root STEM, STEM being science, technology, engineering, and math. So grounding STEM in place, culture, and community with Jason Bruce. You can subscribe to our weekly wave and look for upcoming events on our website, including our upcoming annual conference, which is scheduled for May 20th through the 21st. And early bird registration is now available. So please take advantage of that and join us for our annual conference. I also want to note that we have an exciting internship opportunity. This is available to undergraduate and graduate students. And the deadline to apply is April 7th. So please share that with anyone you think would be interested. Okay, with those announcements, I'm excited to introduce our speaker today. The webinar title is Prioritizing Transboundary Aquifers in the Arizona-Sonora region. We're joined today by Dr. Elia Tapia. She is faculty professor at the Universidad de Sonora in Hermosillo, Mexico. She holds a PhD in arid lands resource sciences, and her expertise includes applied hydrology, hydrogeology, climate change, and disaster risk assessment. Tapia has contributed to the U.S.-Mexico Transboundary Aquifer Assessment Program, called TAAP, and projects for private and public institutions across the U.S., Latin America, and the Caribbean. She has also worked with the Inter-American Development Bank on transboundary water initiatives, focusing on governance, stakeholder engagement, and climate resilience and water resources. Thank you so much, Elia. I'll turn it over to you.
All right. Can you hear me well? Everything okay? Perfect. Well, good afternoon, everyone. Thank you for joining this WRRC Water webinar. I'm really excited to be here today to talk about a recently published article regarding the prioritization of transboundary aquifers in the Arizona-Sonora region. To start this presentation, I would like to express that groundwater is a key water source for the U.S.-Mexican border cities, that persistent droughts over the past 20 years have undermined water security and development, and that climate projections indicate a reduced precipitation over the next 70 years, along with increase in temperatures, and this combined increase the risk of water shortages. In this slide, you can see different images about the drought monitor. These are the most recent ones that you can find online for the month of March. And we see a lot of brown, red colors, orange, that tell us that right now we are experiencing exceptional drought, extreme drought, severe drought. I'm providing an image for the state of Arizona, and I'm providing an image for for Mexico, and then we can just go to the state of Sonora and see that that it is dry, and that we rely on groundwater resources for different purposes, and we need to be able to understand the current status of these resources, and what can we do about this situation. Before we continue, it's important to clarify that the United States and Mexico shared water. They do share surface water, and they share groundwater resources. When this happens, when the two countries or other countries they share groundwater resources, we tend to say that they are comprised within a transboundary aquifer. So a transboundary aquifer would be a groundwater body that spans two or more state boundaries. An aquifer is a permeable layer, water-bearing geological formation underlain by a less permeable water or layer with water in its saturated zone. So important to say that groundwater is an invisible resource. We cannot see it. It's below the ground. So sometimes, like if we are talking about surface water, like we know where the watershed is, we know that when it rains, the river is gonna flow, or we see it, or we always see a river flowing or not flowing. But in the case of groundwater, it is an invisible resource. We cannot see it. And it's important also to know that groundwater knows no borders. So I cannot see it, and it also crosses different boundaries. And in this case, we will be talking about the Arizona-Sonora transboundary aquifers. Some information about the status of groundwater resources around the world. Well, there are around 1,600 transboundary aquifers around the world, and groundwater needs to be understood to be managed sustainable. And we still don't know enough about the state of aquifers. So I can't see groundwater. Groundwater knows no borders, and we still don't know enough about the state of aquifers. If we search online for transboundary aquifers, if we just go to Google and type transboundary aquifers of the world, this should be like the first web page that shows, well, this is a map from IGRAC, from the International Groundwater Resources Assessment Program. So they do have publications. Around every 3 years, they publish this map of transboundary aquifers. This is how it looks. If we zoom to the US-Mexico border, we will see a lot of polygons here that tells us which transboundary aquifers are available, are present within the US-Mexico border. I'm going to move to the next slide. So this topic about transboundary aquifers, how many of those are, or how many aquifers do we share between the US and Mexico? Well, it actually depends on the paper that you open, on the report, on the resource. There is no, we call it consensus, like there's not an agreement yet regarding the transboundary aquifers that we share between both the US and Mexico. So the first image that I show you here, where we see the polygons in green, these polygons are the polygons that are presented in IGRAC. So these are the IGRAC polygons. And then we have some aquifers here in blue, the Santa Cruz Aquifer, San Pedro Aquifer, Mesilla and Hueco Bolson aquifers. Those are aquifers that are currently studied on the Transboundary Aquifer Assessment Program. So this comes from a publication, Megdal and others, 2022. And then there are other publications from Rosario Sanchez. I have this from 2021, but she's been studying a lot or identifying transboundary aquifers along the US-Mexico border. She presents really interesting maps where she identified 36 transboundary aquifers, which are the ones that I'm showing here. And there's different colors for these aquifers according to the level of confidence of transboundary nature. So the aquifers show green if there's a reasonable level of confidence of transboundary connection. Then we have some level of confidence that will allow us to state that they're transboundary. And then we have the red aquifers with limited level of confidence. Sometimes there's not enough information to be able to say these layers are connected to their geological layers, or there is groundwater flowing from one side of the border to another side of the border. So this is a really interesting map, and we actually use it in this prioritization approach. So we have IRAC publications, we have Sanchez publication. They actually are consistent. Like what you see here is what you see here. And I'm showing you to your right a map that it's included in the Sonora Water Plan that was published in 2023. So in this Sonora Water Plan, there's a specific page that talks, a specific section that talks about, they don't call them transboundary, they call them border aquifers. If you see like I left the letters in Spanish and they say border aquifers, because they're actually just projecting the aquifers that are adjacent to the U.S.-Mexico border. And then in that very same section, it says that CONAGUA, the National Water Commission in Mexico, recognizes only 5 official transboundary aquifers. And we have them here: the San Luis Rio Colorado Valley, Sonoita Puerto Peñasco, we have Nogales Aquifer, Santa Cruz Aquifer, San Pedro Aquifer. So if we see, like, if we search through Mexican documentation, those are the aquifers that show to be, or that present that are presented as transboundary aquifers. The rest would be just border aquifers. So there's really not an agreement, as I mentioned, but still there is the interest in keep studying these groundwater bodies. So at the global level, there are some tools that address the need to manage transboundary water resources. I have a picture here of some international conventions: Convention of the Law of Non-Navigational Uses, International Water Courses. We have the draft article on the law of transboundary aquifers, and some other publications, conventions. And it is important to know that all these conventions, all these or articles included in these conventions, they do agree on the importance of information exchange and also in development of studies. So we have these guidelines that are basically general guidelines to, let's say, behave well regarding the use of water resources that cross international borders. So we have these guidelines in some of these articles. It's always expressed that it's important to develop studies. It's important to study more. Why? Because the more you know about a specific region, that serves you to take informed decisions. So that's why this is important. In the United States and Mexico, there is a program that allows the two countries to work on transboundary aquifer assessment. The name of this program is the Transboundary Aquifer Assessment Program. It's a joint effort between the two countries, between the United States and Mexico, to evaluate shared aquifer. The initial, they call them either priority aquifers or aquifers of focus. That's the Santa Cruz, San Pedro, Mesilla, and Hueco Bolson aquifers. Those are the aquifers that are currently studied by the Transboundary Aquifer Assessment Program. Only 4. And they were selected due to many different reasons, including concerns about population growth and growth in groundwater demand, and also water quality concerns, water availability concerns. So from the whole U.S.-Mexico border, transboundary aquifers available and recognizes the top studies for aquifers: Santa Cruz, San Pedro, Mesilla, and Hueco Bolson. So we have here these main aquifers, again, Santa Cruz, San Pedro, Mesilla, and Hueco Bolson. We have them here, we have them here. And this figure, it shows in almost every publication where we are studying one of the main aquifers from the program. So this picture is common. It shows on the WRRC webpage and in many publications. So this program, the TAAP formal U.S.-Mexico cooperation, it began in the year of 2009 under the IBWC cooperative framework, but it actually had its origin in the year of 2006 with a U.S. public law that allowed the allowed the United States to study the transboundary aquifers that I've mentioned. So the U.S. effort started in the year of 2006. Then in 2009, the U.S.-Mexican effort started. And recently in 2023, there was an amendment. This is exclusive to the U.S. regulation, but there was an amendment that proposes extending the TAAP and adding new priority aquifers, this excluding the Yuma aquifer. This means that the list of aquifers that we study, it could increase, potentially increase, and also it's still a proposal, like, but we are working like ahead of time. TAAP advanced studies in the San Pedro and Santa Cruz aquifer in the Arizona-Sonora border region, and the studies that were published, they included water balance modeling, groundwater characterization, hydrogeologic characterization, climate change studies. So we've been working a lot on the assessment of these two aquifers. Right now, we are even at the point of thinking of like start monitoring everything that was already studied. And also we would like to, in the future, if possible, if the stars align, we are thinking that maybe it will be good or a good idea to have a groundwater model, a mathematical model. And when I say we, because I notice that I'm saying this a lot, I mean the binational technical working group that is formed by the different TAAP collaborators or TAAP representative, the technical teams, which include researchers from the University of Arizona, WRRC, researchers from the USGS, researchers from Universidad-Sonora in Mexico, and also we have agencies like the International Boundary and Water Commission, IBWC SILA, that's working as the main agency in charge of this program. And then we also have support in Mexico from the National Water Commission. So if I'm talking, if I say we and we're on a slide that talks about technical work, we is the technical team. Okay. And then, with the study that I'm presenting today, this aquifer prioritization effort, we try to answer the questions, like this question that I have below: where do we start? If I have information for 4 main aquifers, 2 of which are located within the Arizona-Sonora border region, where do I go? What do I do? What should I study? And just thinking about, let's say, if there's limited resources and if I could only study 1 more aquifer, which one would be the one I would choose? This is important. Prioritization is a common practice, and it not only helps to deal with issues related to resources or funding, it also helps with human resources. Like if you are going to be working on something, it's better that it's a place in need. So with this approach that we worked on, develops a multi-criteria method to prioritize transboundary aquifers in the Arizona-Sonora region, supports decision makers in identifying aquifers that require further assessment, uses publicly available data and indicators such as groundwater use, population, and transboundary extent. It aims to optimize resource allocation for regional groundwater research and policy as well. If this is something that serves decision-making purposes, we're also happy to contribute on that. And it provides a replicable framework for the U.S.-Mexico border regions and also for a global transboundary context. So as I mentioned before, prioritization efforts are common. They're globally used. I have some pictures about, again, if you just go Google prioritization and water resources, there are places where they're implementing this for management decisions, for monitoring efforts, and also for conservation efforts. So we have some pictures here about basin prioritization. We have an example of Illinois, California, some stream prioritization tool from the Skyline Alliance. Actually, I wanted to bring this out because they do prioritize areas. and some other publications that you find online. And well, this study will talk about the Arizona-Sonora aquifers, and we use these indicators such as water stress, governance, and socioeconomic factors. So the technique we use is a multi-criteria analysis to prioritize. These words are hard for me, but I think that will be hard for everyone. It's like multi-criteria, prioritization, and transboundary aquifers. Sorry for that. But yes, we use a multi-criteria analysis that are recognized for effectively supporting water management decisions. They allow systematic evaluation and prioritization. This method, it helps decision makers to assign relative importance weights to multiply criteria, and this facilitates a comprehensive assessment of alternatives. It's particularly suitable for integrating diverse factors such as population density, groundwater availability, and transboundary connectivity into decision-making frameworks. So let's say that I want to choose an aquifer, like I have funds for one more aquifer. Should I go for the aquifer that has the more people living in there? Should I go for the aquifer that has like an aridity index that is higher than in the rest of the aquifers? Should I go for an aquifer that has more groundwater wells than other aquifer? Should I study an aquifer where groundwater flows I know that are higher than other aquifers? So there's different indicators, different type of information that can send us a message about the need of keep studying an aquifer. So this multi-criteria assessment, this method, it helps us to basically use them all, even though if you cannot compare them, like if some of them are words and some of them are, let's say, millions of cubic meters, if we're talking about groundwater availability, if another indicator is number of wells, aridity, like all these things, it's not that you can add them and with a calculator and then come up with a score. You cannot do that. You need something in between that helps you translate the results of those indicators so that you get your priority scores. And that's why we use the MCA, the multi-criteria assessment. It's advantageous over single criterion assessment, hydrological modeling, or cost-benefit analysis, as these traditional methods cannot integrate multiple interacting dimensions effectively. So that's why this approach, this method work well, because we have different type of information for the different border aquifers, and we were able to translate them and get scores related to these different criteria that we analyzed. So the criteria that were analyzed on this study, they were chosen based on data availability, reliability, and applicability to other aquifers. So we were searching for data that obviously were available online or easy to access, information that everywhere you look within the US-Mexico border, you could find it, and also information that gives you an idea of the state of groundwater resources. So this is the final list of criteria considered in the multi-criteria assessment. So the first criterion, it's population density. So for each aquifer, we identify population density because this information, it can indicate water demand and potential pressure on aquifer resources. So the more people you have that lives and works and moves within a specific aquifer, well, we can associate that with groundwater use. So for each single aquifers, we determine that information using U.S. Census Bureau information for the year of 2020. We use INEGI information, and we analyze this data using our GIS tool. So it was population density. We also consider transboundary confidence in this case because it categorizes aquifers based on the certainty of cross-border connectivity, reasonable, some, or limited. This framework was established by Sanchez et al. 2016. So higher confidence indicate higher priority, and less confidence or limited confidence would be less priority. Another criterion that was analyzed was groundwater availability. In this case, it measures balance. It's a measure of the water balance between recharge and groundwater extraction. It was calculated using the Conagua. We use Conagua information about groundwater availability. So if we have a positive groundwater availability after as a result of the water balance, that would mean like aquifer sustainability. If we have a negative water balance result, that would be a system with stress or an overexploited aquifer. More information about the aquifer, this would be transboundary groundwater flows. This was also taken from Conagua. So we basically searched through the different publications for the border aquifers, and we tried to find this portion of the water balance models where they determine the transboundary groundwater flow. We consider transboundary groundwater flows. And we also have, it says groundwater flows. I apologize. It should say groundwater wells. In this case, we count registered wells as a proxy for extraction pressure. Sources of information, they include the Department ADWR resources, GIS portal, and wells from Mexico were taken from the Public Registry of Water Rights from Conagua, Mexico. In this case, we assume that a higher number of wells suggests greater extraction and higher aquifer priority. We also included an aridity index. We developed an aridity index indicating climatic stress using the ratio of precipitation to potential evapotranspiration and barren land cover changes. Lower AI indicates higher aridity calculated from the TerraClimate datasets. Another piece of information that was considered, it was irrigated lands. Measure areas irrigated by groundwater, directly reflecting water demand. This data came from FAO, from the World Bank maps of irrigated areas, and they're expressed in hectares. So this is the criteria that was used for determining or for prioritizing aquifers. So of course, there are many other criteria that could be used to assess the level of priority of an aquifer. But again, it was important that the information was available for each single aquifer. I will provide an example. It was really important for us to be able to project data about water quality as well. If there were measures about water quality in both sides of the border, we would probably have included this as a criteria, but we didn't. Why? Because we did find water quality information, but not for each single aquifer that we were studying. And we want this method to be able to, we want to be able to replicate this method in other regions, first in the US-Mexico border, and then it is a method that can be replicated somewhere else if it is possible to find something similar to groundwater availability information and also to transboundary groundwater flows. So because that's produced by Mexico. So if this wants to be implemented in other countries, similar information to groundwater availability and transboundary groundwater flow should be available. Well, that's with that said, I'm gonna go one by one, showing the data that was used as an input for the multi-criteria assessment. So I'm going to show you here some of, the criterion was population density. In the map, I'm showing you just population. So density would be the population divided by the area. So we have here that we created different maps for the Arizona-Sonora border aquifers, and we tried to count how many people live within the aquifer boundary. So we haven't seen we haven't really seen this type of information published elsewhere. We tend to describe an aquifer, and we tend to say that, let's say that the aquifer is comprised within In Mexico, we call them municipalities. In the US, could be a county subdivision. So we tend to say this aquifer, it's comprised within the San Luis Rio Colorado municipalities, Yuma County subdivision, etc. But we actually did this GIS assessment where we searched for each little town and city comprised within the aquifer so that we know how many people live there. And this is a really nice finding. We received questions already on how did we come up with this information, because some of the aquifers, they had like really low population density or people living within the aquifer, and then we just show the map, and you could see, like, for example, here the Los Vidrios Western Mexican drainage, like there's not a lot of population living within the area. So if this is part of the criteria that's used in the multi-criteria assessment, that would, like, depending on the rest of the results, I would say that Los Vidrios is not a highly populated area, and maybe I don't want to study this aquifer first. So this was like what we were trying to achieve with this type of assessment. So now we move to the Sonoita Puerto Peñasco, San Simon Wash, population, Arroyo Seco aquifer. So I have to clarify something here before I continue. According to the Sanchez et al. Publication, the IRAC publications as well, there are 10 transboundary aquifers within the Arizona-Sonora border region. Only 5 of those aquifers are recognized by CONAGUA, as I mentioned. So from these 10 aquifers of study, 2 of them, they didn't make it to the final assessment. These 2 aquifers are the Valle de San Luis Rio Colorado Yuma aquifer. It didn't make it to the final assessment because the Yuma aquifer is not a TAAP aquifer of interest, and is not an aquifer that would like to be an aquifer of interest. So we had to take the Yuma aquifer out. And we also have an aquifer, the Arroyo Seco aquifer. We have limited confidence, I believe, in the transboundary connection, and we believe that the aquifer boundary needs to be revised because it goes up to Florence, it goes up to Tucson, and well, first of all, it is important to revise, to check the groundwater formation here, if groundwater is connected and goes until this area, which we believe not. And also, for example, the sources of water in Tucson and other regions is not entirely groundwater. So this aquifer is not included on the assessment. Then we move to the Rio Altar aquifer, Rio Alisos aquifer, not really crossing the border, but still consider, or still in our list of aquifers to be assessed. Then we have the Santa Cruz aquifer and the San Pedro aquifer, their population, GIS information that is presented here, and the data, these dots, we're talking about different towns, ranches, cities, etc., with the population that lives within there. And what else we can say from here? Well, it's in our, this is also it's a harmonization effort. It's information that comes from different sources, sometimes even different, like coordinated systems, and so it's like putting this together. Even though the paper only presents a table, like, it's a huge effort to be able to create this. So we have the Douglas Agua Prieta aquifer. We have the Arroyo San Bernardino aquifer. For this aquifer, we received a question because it's not a highly populated aquifer, and for that reason, it went to, like, the lower scores of prioritization. And we can see that the aquifer actually crosses the county subdivision of the Douglas region, and it actually crosses the county subdivision of Elfrida. So if we read the article, we could think, oh, it crosses Douglas, but why is, like, the population so low there? And this is because we are just considering the towns that lie within the aquifer boundary. So this is what we have for the Arroyo San Bernardino. Then we have the next criterion would be transboundary confidence. We took information from Sanchez et al., Sanchez and Rodriguez 2021, but we've seen publications that date back to 2016 as well, where information is presented regarding the identification of transboundary aquifers. So this information, it's included as one of the criteria that's considered in this assessment. And so we have it here. Then for transboundary groundwater flow, as I mentioned before, we use information that's been published by CONAGUA. So we have the different water balance models that were considered. We have the aquifers of study, and the most recent publications that we were able to find, it's from the year of 2024. So if there was a sentence or if there was a reported transboundary groundwater flow in this report, we added to the analysis. In addition to the information about the transboundary groundwater flow, the transboundary that crosses the border, we also consider groundwater availability. The source of information for groundwater availability is also the National Water Commission Water Balance Studies, Water Availability Studies. So basically, if the aquifer showed as an aquifer without availability, if the aquifer showed red, that would mean that the aquifer should have a higher priority than the rest of the aquifers. So any of these aquifers that show red, it was higher priority than the rest, okay? Then we have here the groundwater wells for the different aquifers. Information, as I mentioned, it came from the ADWR, Arizona Department of Water Resources in the US, and it came from the Public Registry of Water Rights in Mexico. So we downloaded data from these different sources, harmonized information, and presented it. In here, you are seeing the map. In the paper, in the journal article, you're just going to see how many wells there are in the U.S. portion of the article of the aquifer, in the Mexican portion of the aquifer, and then the total. And this is like a more visual or images that provide us some idea of the number of wells. So this information, it comes with an assumption. So the level of priority would be based on the number of wells available. So the more wells we have, the higher the priority. We understand, and we would like to express that it is also important to know like the amount of groundwater extraction of those wells, because it is possible that you have 500 wells in a region and they extract less water than an aquifer that has, I'm being dramatic, 20 wells. So we know that this information, like if you keep like investigating or working on this, you know that sometimes the number of wells can like deviate from the answer. So this is an assumption that was made in this study. Why? Because there wasn't information, like comparable information regarding either groundwater extractions or groundwater levels for all the aquifers of study. And we also depart from the premise that if this happened in the US, in the Arizona-Sonora border region, it will keep happening in the rest of the US and Mexican states. So the data that we were able to find that it was the same data, comparable, homogeneous, was number of wells. So these are this is information that was included. We have different aquifers, Santa Cruz, San Pedro, a lot of mapping that I'm glad that I was invited to present here, because otherwise you wouldn't have seen them. The paper had no space for that, so I gave you a table that I'm going to show later on. So we have here the groundwater wells and the aridity index that was calculated. So we have like different values for the aridity index. The less the more arid region that we were able to find was first place Arizona, Valle de San Luis, Rio Colorado, Yuma, but it was not considered on the assessment. Then we go to Los Vidrios, Western Drainage, Sonoita, Puerto Peñasco, Arroyo Seco, not considered, and then the rest of the aquifers. And they're always in the same order from left to right. And yes, it's like more arid to less arid, actually. So if we can make that comparison as well. Irrigated lands, we also included them, assuming or considering that agriculture is one of the activities that uses more water in the U.S.-Mexico border, in the world, etc. Well, it uses around, I think it accounts for around 70% of the water that's used in the state of Sonora. So we have this this information about the irrigated lands, so that we can relate it to groundwater use as well. So regarding the process, let's talk a little bit about the assigning of weights. Weights were assigned to each criterion because they determine the relative importance or influence on decision making. The study, as I mentioned, employs a multi-criteria assessment effort, or it's also called the analytical hierarchy process. Publications, well, the most common publication that you'll find is SARI 1987, but after that, the same author kept publishing work about prioritization, and then we have different applications of its methodology. So in this publication, a structured MCA framework was published to determine criteria weights through systematic pairwise comparison. For example, criteria specifically relevant to transboundary aquifers, such as transboundary confidence and transboundary groundwater flows. In this assessment, they receive higher weights due to their critical importance. Each criterion is directly compared to others using a scale: equal, moderately more important, strongly more important, to build a comparative matrix reflecting relative preferences. The information was normalized using comparison matrices, and then we ended with the final calculation, the priority calculation, that consider the priority level would be equal to the weight of one criterion plus the weight plus the result, their weight plus the result, and then you get the priority level. And I know that this might sound weird and I'm talking a lot, and this slide is full of letters, so I'm going to move to the examples, okay? So the criteria considered in this assessment, as I mentioned, included population density, transboundary confidence, groundwater availability, transboundary groundwater flows, number of wells, aridity index, and irrigated lands. So for each of the aquifers, we search for that information. So let's start here with the Los Vidrios Western Mexican drainage. So we have the area, we have the groundwater extraction, groundwater flows. If there is give me 1 second because the slides are blocking me. Well, okay. The slides are the Zoom line is blocking me the first sentence. But we have groundwater flows, we have groundwater wells, and aridity index, irrigated land. So for each aquifer, we search for that information. I show you the sources of information already. So we have it here. If there's a limited transboundary groundwater confidence, if there, this is one of the most interesting findings. Like if you see the groundwater availability studies, like the water balance results for change in storage, like we have aquifers that are in serious deficit. We can see that in the Sonoita Puerto Peñasco area with minus 83.72 millions of cubic meters per year deficit. Then we have the San Pedro with a deficit as well. We have the Douglas Agua Prieta with a deficit as well. And then the rest of the aquifers, they have 0, 0, 0, 0, 0. Well, that means the aquifer is in equilibrium, no more, like, it's not that they're in a positive or positive state. It just means that they're in equilibrium. So the best that we were able to get in the border region was a 0 water availability, and then some groundwater flows, number of wells, etc. So this is just a summary of all the information that was analyze it for this study. And then in here we have the list of criteria: population density, transboundary confidence, groundwater availability, transboundary groundwater flows, the number of wells, aridity, and irrigated lands. We have here the different weights, and they were determined using this study 1987 methodology, where you just basically made comparisons. Let's say population density versus transboundary confidence. What is more important, population density or transboundary confidence? So we started determining weights according to the level of importance, and it's always like the weights, they can change depending on the purpose of the study. So the purpose of this study was to find or to identify aquifers that should be prioritized. So that's why, for example, the transboundary confidence was an important variable to analyze, because like I wouldn't be studying an aquifer that I don't know that it's a transboundary aquifer for sure, because there's not enough information. So transboundary confidence was important. Transboundary groundwater flows also important. Why? Because if there's no water flowing, like this is a study for transboundary aquifer assessment. If it were a study for just not transboundary, just water moving, or just an aquifer without the transboundary component, maybe this would be different. That's something that needs to be clarified. Then we have here the different alternatives, the different options that you could get, and then the weight that you will receive per option. And then I have the different units of measurement. So let's say that I have an aquifer where there is a reasonable confidence that it's a transboundary aquifer. Then that would mean that my weight would be 0.53. Then I would choose the option reasonable, and then I would multiply it by the 0.226. And if the transboundary groundwater flow, let's say it's it goes from 120 to 160 millions of cubic meters per year, then my weight would be for the alternative will be this, and that will be multiplied by the weight of the criterion, and that will bring me a numerical result where the higher value that I get for these aquifers, the higher value would be the higher priority. So there we have it with a picture. So we have population, again, population density, transboundary confidence, groundwater availability, the flow, the number of well, aridity, irrigated lands, and that together will give me the level of priority of transboundary aquifer assessment. So in here we have the results of the, it's like a mirror of the first table that I showed you with the aquifers and the data gathered. But in this case, I'm not using the information that the information that was gathered. It was like basic, as I mentioned, basically translated using the MCA approach. So that instead of words, instead of seeing reasonable, instead of seeing population and millions of cubic meters, like I have comparable information, and I can rank the information according to according to the level of priority. So we have here the different priorities. We have the Sonoita Puerto Peñasco on the first place. Why? Because it's a super arid region. It was top on the aridity index, top on the groundwater availability index also. So, and there were a lot of wells as well. So that's why Sonoita Puerto Peñasco went top. Then we have the Santa Cruz and San Pedro aquifers, second and third place. This is consistent with the Transboundary Aquifer Assessment Program. They are aquifers of interest. And then on the fourth place, we have the Douglas Agua Prieta aquifer. And then we have, with less priority, Los Vidrios, Rio Altar, Arroyo San Bernardino, and Rio Los Alisos, due to a combination of the different indicator, due to a combination of the different criteria that were considered. So the result is the combination of the criteria, not one or another one. It's all of them. That's the result that we got. So like trying to find them on the transboundary aquifer map, we have the Sonoita Puerto Peñasco first, we have Santa Cruz, San Pedro, we have priority, and then we have the Douglas Agua Prieta aquifer. So the Douglas Agua Prieta aquifer, as I mentioned, is not in the list of transboundary aquifers that are recognized by Mexico, but there has been some interest in keep studying or study this aquifer more. So maybe this information, this publication can serve as a guide to see what's next, what to study, what should we do, what should we assess. And also, let's say that Rio Altar, Rio Los Aquíferos, Rio Los Alisos, for example, like if they don't show enough evidence of transboundary connection, maybe a study about the different geologic units will help us to understand if it's a groundwater body that's connected to the other side of the border. So there's different findings here. Highest priority, as I mentioned, Sonoita Puerto Peñasco. Why? Because it had a reasonable transboundary confidence, because it had a groundwater deficit of minus 83.72 millions of cubic meters per year, 525 wells, more than 5,000 hectares of irrigated lands, and an aridity index of 19.2%. Then we have the current TAAP aquifer, San Pedro and Santa Cruz. In here, we have groundwater availability that goes from 0 to minus 6.17 for the San Pedro. So we do have groundwater deficit in the San Pedro, but it's not minus 83, like in the Sonoita Puerto Peñasco aquifer. Then we have the next priority aquifer, Douglas Agua Prieta. We do have a water deficit, minus 0.05. Wells, 4,136, irrigated land, 5,000 hectares, and a aridity index of minus 12%. Lower priority aquifers, we have Los Vidrios, we have Rio Altar, Arroyo San Bernardino, and Los Alisos. In this case, we received a moderate to low priority and lower immediate need. As a discussion, I would like to say that this assessment, this type of assessment, the multi-criteria, is widely used in water resources decision-making. Criteria tailored to specific regional objectives. As I mentioned, it depends on the objectives, your criteria, your weight, and the way in which you put together the information. It's tailored to specific regional objective. If the objective change, criteria change, and weights as well can change. Some of the criteria selection and limitations that we have is that, for example, I mentioned this already, water quality was excluded due to inconsistent binational data. There were data available. Yes, there's different like databases. Some of them are ArcGIS based, where you can just go and download data and place it on ArcGIS. Sometimes we were able to find like tables with information, but it wasn't consistent, not for the whole border region. So we couldn't use that data. Also, at the beginning, like the first conversations we had regarding these prioritization efforts, we really wanted to include like something that has to do with governance or hydropolitical factor. At the end, they were excluded, first of all, due to quantification challenges, and then also because we were searching information about the groundwater, the status of the groundwater resources. So talking about, yes, we have an agreement. No, we don't have an agreement. In two countries that actually don't have an agreement on groundwater resources, well, it was going to just deviate from the purpose of the assessment. And also, this highlights the need for binational standardized monitoring effort in the whole border region. And future recommendations for this research study includes also stakeholder engagement for complementary insights. The methodology is replicable, adaptable, and robust for future assessments. And dataset supports informed management and responsible aquifer use. So you can just read the paper for just learning about this methodology. You can read the paper just to just see the rank and try to to identify the aquifers more in need of assessment. Maybe if we have students here, they would like to study, let's say, the Sonoita Puerto Peñasco aquifer, and also like the rest of the data sets, number of wells, population, groundwater availability. These can also help for informed decision making. So the paper, the publication, it's helpful for different areas, not only academia. So conclusions for this research is that the multi-criteria approach effectively identified transboundary aquifers needing further assessment. San Pedro and Santa Cruz aquifers are confirmed as high priorities, aligned with the TAAP interest. The Sonoita Puerto Peñasco San Simón Wash ranks highest due to severe groundwater stress. Data gaps and inconsistent monitoring across the board limited some criteria, yes. And despite the limitation, binationally available data reveal key stressors on groundwater availability. And this framework supports future assessment and is applicable to other US-Mexico border regions and also is applicable to other global context. So with this, I finish this brown bag presentation, and yes, I guess we can move forward with questions or concerns about this method or the data that was presented in this webinar.
Wonderful. Thank you so much, Elia. So just as a reminder, our webinars go until 1:15. So we do have about 20 minutes for questions. We realize some people may have to leave at 1 o'clock, but our Q&A will go until 1:15. So just to start, not more, just some congratulations, Elia. Several people mentioning great presentations, great graphics. A question from Nazine, will the presentation be available after the session? Yes, so there's a link there and we will post the presentation. Getting into some of the other questions, there were a couple questions about which criteria to include. So I'll combine two questions, one from Randy Hansen and one from Walker about, what could be included. So is it possible, is there any merit in adding industry such as maquiladoras as an additional demand criteria with population and agriculture? So industry, maquiladoras. The other one from Walker Kosar, have you considered rate of change of population or growth in the prioritization? Oh,
okay.
there you go.
Yeah, yes. So let's say for the first question, one of the well, it's under the discussion session, and also I said this on my final slide. Stakeholder engagement is important in this process. So I don't think this is going to be just an article about prioritization. Actually, this type of interactions, they're really helpful, because now that you're telling me, oh, let's add industry, of course, let's add industry, because like if we are in an area where we have like mining activities, or if we are in an area where we have maquiladoras, that would probably add stress on groundwater use. So right now we have the number of wells, as I mentioned, but what if it's like a big time well that uses water for a for a big industry? So sorry, I've been talking for like 3 hours, and Jamie knows like no, it was 2 hours, not 2 hours. But yes, I like the comment about the industry. I hope we can present this more to different stakeholders and continue with the research and refine these criteria. They should be refined, and they should be based on input from different stakeholders. So I would like to call this also a success in terms of stakeholder interaction. And if you have a comment about additional criteria that we could use, we can do it. It's important to note that this research, it uses like available information that was homogeneous, that was that we could just graph for the two countries and was similar. So adding industry, it would require to do, let's say, some field work or to try to go one by one to find the number of industries. So it is possible, but at this point, like, it wasn't part of the scope. So thank you.
Okay.
So,
yeah. And then we can add population change growth maybe to that list.
Yes. And the next question is the same. We just talk about density, but population growth would definitely be something that could be considered as well.
Great. And then somewhat related, Peggy is asking about groundwater wells, specifically in the Patagonia area. Will water well data reflect new local mining concerns? So I guess maybe kind of getting at that, is there a way to incorporate mining water use through the groundwater?
Okay, so the well data that was downloaded, it came specifically from ADWR, and the most recent information that they had on their webpage, and the same for Mexico. So the wells used for the industry, it was assumed that they were there. But as I mentioned, we only like counted the number of wells, and we don't know how much water they pump. So that's another area that we could explore. Now that we know where they are, a next step would be to just try to find how much water they use. And this is tricky because in Mexico, you don't really find data for each single well. What you would find is what they call a concession that's similar to a water right. So for the Mexican side, we will know the location of the well, and we will know the concession, that's the water right. And then in the US, we will have to search for the groundwater extraction, and I believe that it would be like one by one for each of the wells, and sometimes the information is not publicly available. So sometimes there's people that opt to say, I don't want this information to be out, and then you don't find the information, and it's not included on the assessment. So it's something that we need to think about some more. And I'm saying out loud a lot of like you're giving me such a great ideas, but at the same time I'm realizing that it's a lot of work that can be done. So well, it's exciting to continue with this, and that was the purpose of this presentation and the purpose of the paper itself. So I'm happy to get all these comments.
Great. So another question about the assessment process. This is from Dave Wegner. He's wondering if you did a sensitivity analysis. I know you did the weighted criteria, but did you do a sensitivity analysis of the 7 data metrics to determine which ones provided the most impact on the characterization of the aquifer prioritization?
Oh, yes. The sensitivity analysis is under the calculation. It didn't take it to the presentation, but we do have some percentages, and there was this like error calculation, and so we do have that. It is considered. It's not just me throwing you data. No, Dr. Megdal wouldn't allow that for sure. Mm-hmm.
Okay. There were a couple of questions about the maps, and I know that you started that very early on in your presentation, describing how there's not necessarily consensus around what's considered the transboundary aquifers. But one person, Kara, asked about a link to the map, and so Jesse posted that link. And Randy made a comment about the transboundary maps, and was suggesting that they use aquifer boundaries of the U.S. and jurisdictional regions in Mexico. And a good example is the correct definition of the Rincon/Mesilla Conejos Medanos by the USGS 2017-2020. So I don't know if you have a comment or response to that. Sort of, he said the transboundary maps are incorrect, but you also commented early on that there's not necessarily consensus.
I said. Yeah, it depends on the report that you open. What you have to say always, and I think I did, is the reference of the aquifer boundary. So my reference would be IGRAC 2021. And yes, I can check on the USGS boundaries that you are commenting, and yeah, as a follow up and to see how different they are from the ones we have. Luckily, the map is referenced in the paper and in this presentation. So yes, we work with IGRAC delineations, and also we work with the Sanchez and others delineation. I understand that there's different boundaries, and as well, I don't know if I have people from Conagua here, but yes, if there were something from Conagua, it would be a similar comment. So I apologize for all the people if I didn't use your aquifer boundaries. But yeah.
And another question from Randy, he's asking about the use of a specific model. Let me see his question here. Did you use the MFOWHM integrated hydrologic model for the Mexicali Valley from the Universidad Autónoma de Baja California Sur as part of the assessment of the Mexicali Valley?
For this research, we didn't, because we're not studying the Mexicali Valley. It is a great reference though, and it was important that whatever we use, we would have like the same for each aquifer. So probably it's something that would be interesting to explore, but I would have to like have similar information for each aquifer in the Arizona-Sonora border region, and if we want to keep doing this for the rest of the border, we should have the same. So that's one of the reasons why this isn't included. What we do have consider, and as I mentioned, is the publications from the National Water Commission, their water availability results, and also their transboundary groundwater flows. I know that some of them and people sometimes they express that they have limitations, these publications, but if let's think this way, if a CONAGUA report says that it's a minus 87 point something groundwater deficit, there is deficit in the area. So that's why we were able to use the data and add a rank according to this deficit calculations. Mm-hmm.
Great, thank you. There's I believe a follow-up question related to this sensitivity analysis. And I'm a social scientist, not a technical person, so I hope I'm connecting these questions together okay. But Ben Scandalia is asking, did you test the sensitivity of the prioritization to different criteria weightings that would arise from the pairwise comparisons by different people?
By different people. So yes. So we tested this with the different authors of the paper, right? So and we also had discussions at the beginning of this effort to talk about the weights and the criteria, etc. The USGS was really helpful. We have and actually I thank Gilbert Anaya, I thank James Calgary from Gilbert Anaya from the IBWC, James Calgary from the USGS, and also Anne-Marie Mathern from the USGS, because they helped a lot in the previous stages of the development of this journal article. So we had some like serious conversation about this comparison matrix. So it was part of the initial efforts. It's also one of the recommendations that we have for the paper, that we consider stakeholder engagement. And when I mention stakeholder engagement, we should just test with different stakeholders what weights would they assign to the different criteria, so that we make sure that it's not like I'm not biased and I want to just take into account groundwater flows and I should be taking into account something else. So stakeholder engagement is an important process of the MCA. We see it as a next step on this study, and thank you for bringing this comment out. If it weren't there, I wouldn't have mentioned this, but yes, it's important to have the opinion of people. So right now someone said, oh, let's have industries. Great. Maquilas, mines, etc. That's great. But also it's important to, as a next step, see or evaluate the ways that have been used. And that could be like a second paper. And if you have more comments, I'm happy to receive them. I didn't let my email. I can type it in the chat, and I'll be happy just to keep answering questions and keep working on this.
Wonderful. Thank you, Dr. Tapia. While you're writing your email in there, I appreciate it. I'm taking a look at the chat and I don't see any additional questions. If I missed one, please let me know. There's Elia's email for any follow-up. And unless I hear of another question here in the next minute, we can wrap up. And Elia also presented in Dr. Megdal's class, water policy class earlier this morning. So yeah, you've been busy this morning. We really appreciate it.
Thank you.
Okay, well, I am not seeing any more questions or hearing any more questions. So please join me in thanking Dr. Tapia again for this excellent presentation. And we'll see you at our next presentation, April 11th. Thank you. Thanks, Elia.
Thank you so much. Thank you.